In 2019, Boeing proudly revealed their latest aviation marvel, the 777X. It was sleek, enormous, and promised to revolutionize long-haul travel. But as soon as engineers unveiled the plane's folding wingtips, eyebrows across the aviation world shot up. Folding wingtips? On a commercial airliner? That was unheard of. Sure, folding wings were common on military jets and aircraft carriers, but commercial planes? Never. And Boeing didn't just introduce them. They were betting the future of the 777X on this bold design. But why would Boeing gamble on such a risky feature? And what hidden problems did this radical design choice create? To understand Boeing's high-stakes move, we have to go back to the growing problem at the world's busiest airports. By the late 2000s, airports around the world were running out of space, runways and taxiways were packed, and wide-body planes were already pushing the limits of airport infrastructure. There are strict international rules that classify airports based on how big a plane's wingspan can be. Boeing wanted to build a plane with longer wings to increase efficiency and reduce fuel burn. But here's the catch. If the wingspan went beyond 65 meters, airports would need to upgrade their gates and taxiways. That would mean fewer airports could handle the plane, and airlines don't like that. They want flexibility. So Boeing faced a choice: keep the wings short and sacrifice efficiency, or make them long and risk the 777X being banned from most airports. But Boeing had a third option, a gamble no one in commercial aviation had tried before: folding wingtips. And that decision would come with risks no one fully saw coming. By adding folding wingtips, Boeing could have it both ways. The wings could stretch out to 71.8 meters during flight, improving aerodynamics and saving fuel. But when the plane landed, the tips could fold up, keeping the wingspan under the 65-meter limit. Problem solved, right? Well, not quite. The aviation industry had never put moving parts like this on a commercial wing's outer edge, and that raised critical safety questions. What if the wingtip failed to lock into place? What if it accidentally folded during takeoff or landing? Boeing had to prove to regulators that the folding mechanism was absolutely fail-safe. They built multiple redundancy systems, added extra sensors, and created manual overrides for pilots. But as Boeing's engineers worked to perfect the system, they discovered a surprising challenge they hadn't fully expected. And we'll get to that in a moment. Folding wingtips sound clever, but they aren't free. The hinges, the locking systems, the sensors, the backup systems, they all add weight. And in aviation, weight is everything. The 777X's folding wingtips ended up adding several hundred extra kilograms to the plane. Boeing had to offset this by optimizing other parts of the aircraft. They introduced new lightweight materials, reworked the wing structure, and squeezed efficiencies wherever they could. But the extra weight wasn't the only problem. The added mechanical complexity increased the maintenance requirements. Folding wingtips needed to be regularly inspected, tested, and serviced. And that made some airlines a little nervous. So why did Boeing push ahead with this gamble? The answer lies in their fierce competition with Airbus. By the time Boeing announced the 777X, Airbus had already launched the A350, a fuel-efficient, long-range competitor with a conventional wing. Boeing couldn't afford to release a plane that was less efficient than the A350. They needed a big aerodynamic advantage, and longer wings were the fastest way to get there. The folding wingtips were Boeing's answer, a high-risk, high-reward move to leapfrog Airbus. But there was one more twist. The folding wingtips weren't just a bold design choice. They were about to trigger a regulatory first that the aviation world had never seen. When Boeing presented the folding wingtip design to aviation authorities, it became clear that there was a problem. The existing certification rules didn't account for commercial planes with moving wingtips. Sure, military jets and carrier-based planes used folding wings all the time. But commercial aviation? Completely uncharted territory. The Federal Aviation Administration, FAA, had to create new regulations from scratch. They had to ask tough questions. What happens if the wingtip doesn't lock properly? Can the system fail in flight? Can it fold accidentally on the ground while taxiing? Boeing had to prove that the wingtip's locking mechanism would automatically engage every time, with multiple layers of redundancy. If the system failed, pilots needed to have manual overrides that worked instantly, and the plane had to give clear cockpit warnings if anything went wrong. This was a certification process Boeing had never faced before. And it wasn't just about passing lab tests. The folding system had to prove itself in brutal, real-world conditions: freezing cold, scorching heat, heavy rain, strong winds. But Boeing pushed forward because the folding wingtips weren't just a nice-to-have feature. They were essential to the 777X's success. By the time Boeing entered the final design phase, Airbus was already securing orders for the A350 from major airlines around the world. Boeing couldn't afford to release a plane that was slower, less efficient, or limited to fewer airports. They needed something that could outmatch Airbus in range, efficiency, and capacity. The folding wingtips gave Boeing an edge. When fully extended, the wingspan delivered serious aerodynamic benefits, reducing drag and saving fuel. And when folded, the 777X could fit into the same gates and taxiways as its predecessor, the 777-300ER. It was the perfect pitch: more efficient, airport-friendly, and innovative. Airlines loved the idea, on paper. But there was still one big unknown. What if pilots didn't fully trust the system? From the cockpit, the folding wingtips introduced a completely new checklist item. Pilots now had to verify that the wingtips were fully deployed and locked before takeoff. The system was designed to give multiple visual and audible confirmations, but it added one more potential point of failure to an already complex pre-flight routine. The FAA required that the system automatically unlock and fold the wingtips after landing. But what if the plane landed in high crosswinds or on uneven tarmac? Could the folding mechanism jam? Boeing's engineers worked hard to eliminate these concerns. They built test rigs, simulated extreme scenarios, and refined the design repeatedly. But the folding wingtips remained a new variable in a world where pilots and regulators prefer proven, time-tested systems. It was a risk Boeing was willing to take. And as the 777X entered the final stretch toward certification, there was one more surprise waiting. The folding wingtips weren't the only challenge the 777X faced. Delays with the plane's massive GE9X engines, issues with software, and the aftermath of Boeing's 737 MAX crisis slowed the program dramatically. The 777X was supposed to enter service by 2020, but as of now, deliveries are delayed until at least 2025. Every year of delay costs Boeing money, market share, and momentum. And the longer it takes, the more Airbus strengthens its position with the A350. Ironically, Boeing's most innovative feature, the folding wingtip, isn't the reason for the biggest delays. In fact, the folding system passed its safety tests and performed reliably in real-world trials. But Boeing's gamble isn't over. The 777X still faces fierce competition, stricter certification, and the challenge of winning back trust after years of turbulence. The folding wingtip on the Boeing 777X started as a solution to an impossible problem: how to build a bigger, more efficient plane without making airports obsolete. It was a risky move. It introduced mechanical complexity, added weight, and forced regulators to rewrite the rulebook. It gave pilots one more system to monitor and required airlines to trust an idea never before used on commercial jets. But Boeing's gamble is also a glimpse into the future. As planes grow larger and airports remain constrained, folding wings may become the new normal. In fact, Boeing's success with the 777X folding wingtips could pave the way for even more ambitious designs. The folding wingtip is no longer just a bold experiment. It's now certified, tested, and flying. What once seemed like a dangerous gamble is quickly becoming a defining feature of next-generation aircraft. Boeing's solution wasn't just clever engineering. It was a high-stakes bet that the future of long-haul aviation needed a new kind of flexibility. And despite the delays, the folding wingtip might just be the feature that keeps the 777X relevant for decades to come. So, was Boeing's risky gamble worth it? Only time will tell. But one thing is certain: Folding wings are no longer just for fighter jets. They now belong in the sky, carrying passengers around the world, one folded tip at a time.